Nothing should be coming from out there. Not like this. Not at that speed, not from a direction that doesn't belong to our neighborhood of space. Because when you look into the black between the stars, your brain assumes it's empty, quiet, dead. But the universe doesn't care what your brain assumes. And right now, something from another star system has already crossed the border into ours. A real interstellar visitor. Not a theory, not a sci-fi maybe, but a confirmed object on a hyperbolic path that will never orbit the sun, never settle here and never come back. It's called 3I Atlas, and it's racing through the solar system so fast that if you blink, you miss the most important part, what it proves. Because this isn't just a comet, it's evidence. Evidence that the space between star systems is not quiet. Evidence that other solar systems are constantly throwing material into the galaxy. And evidence that if objects like this can drift for millions, maybe billions of years and still arrive intact, then the Milky Way is not a collection of isolated worlds. It's a connected ocean full of debris and potentially full of messages we don't even know how to read yet. Let's get one thing clear before we go full cosmic paranoia. Nobody at NASA is saying this is alien technology, and I'm not going to tell you aliens confirmed. What I am going to do is show you why scientists care so much about this kind of object, why the data matters, and why the implications are bigger than most people realize. Because when the third confirmed interstellar object shows up, you stop calling it a fluke. You stop calling it a once-in-a-lifetime weird thing. At some point, the pattern becomes the story, and the story is simple and terrifying in the best way. We are not isolated. We are being visited by the leftovers of other star systems, whether we like it or not. So what is 3I Atlas? It's classified as a comet, an icy nucleus surrounded by a coma, that bright cloud of gas and dust that forms as sunlight heats the ice, and it starts releasing material into space. It was discovered by Atlas, a NASA-funded survey telescope that scans the skies, and it was reported in early July 2025. That Atlas part of the name matters because it tells you this wasn't found by accident. This was found because we're finally building the tools that can catch fast, faint intruders before they're gone. And the 3I part matters even more. It literally means it's the third confirmed interstellar object ever observed passing through our solar system. Third, not first, not the weird one. Third, that number should make your skin tingle just a little because it tells you the galaxy is probably throwing these things around far more often than we've been able to see. Now here's where it gets interesting, and where your brain starts doing that thing where it tries to picture scale and fails. Interstellar doesn't mean from another planet. It means from another star system, ejected into interstellar space, the deep, cold region between stars, then drifting until it wandered close enough for the sun's gravity to grab it briefly and bend its path. For millions, maybe billions of years, this object was essentially a cosmic ghost. No sun to warm it, no planet to orbit, no friendly neighborhood, just the long dark. And then, on one random slice of time in 2025, it entered the solar system and we noticed it. The scary part is not that it happened. The scary part is, how many times did it happen before, when nobody was watching? The reason scientists immediately knew it didn't belong here comes down to one word: trajectory. A normal comet in our system is bound to the sun. Elliptical orbit, returns again, part of a family. But 3I Atlas is on a hyperbolic path. Hyperbolic means it's moving too fast to be captured into a closed orbit. The sun can bend the path, accelerate it at closest approach, and then it keeps going. That's a one-time visit, a drive-by through our cosmic neighborhood, with no intention of staying, because it physically cannot stay. That's how you know it's an interstellar traveler. It's not just far, it's unbound. And the speed is not a cute detail, the speed is the headline. When it was discovered, it was moving at roughly 137,000 miles per hour. As it fell deeper into the sun's gravity, it sped up even more, around 153,000 miles per hour at perihelion, its closest approach to the sun. Those numbers are so violent that they don't feel real, but they are. And this is why we can't treat 3I Atlas like an ordinary comet. It's not just a snowball from our own backyard. It's a bullet from another neighborhood passing through ours, carrying material shaped by a different star, different planets, different chemistry, and a different history. Now, if you're thinking, okay, cool, but does it threaten Earth? The answer is no. It doesn't come anywhere close in planetary terms. Its closest distance to Earth is still about 1.8 astronomical units, roughly 170 million miles. And NASA is very clear that it poses no danger. That matters because the internet loves turning every space rock into an extinction event. Not this one. This is not about fear of impact. This is about the fear of what we're learning about the galaxy. So why is a comet from another star system such a big deal? Because comets are time capsules. They preserve primitive material, the kind of stuff that forms planets and atmospheres. When you study a comet from our own solar system, you're studying our own origin story. When you study a comet from another star system, you're studying an origin story that isn't ours. You're holding a piece of a different solar system's construction debris, and that means you can compare. You can ask, are other star systems built from the same ingredients? Do they have the same ratios of certain molecules? Are their icy bodies richer in certain compounds? Are they darker, redder, more volatile, less volatile? If 3I Atlas looks normal, that's a discovery. If it looks weird, that's a discovery. Either way, it's priceless science, because you don't get samples like this delivered to your doorstep very often. But here's the cruel part. We don't get to keep it. This is not a mission we planned, it's a cosmic ambush. It shows up fast, it passes behind the sun for a time, it re-emerges, and then it's gone. Out past the planets, out past Jupiter, out into the dark. And every day it's farther away. That means observations are a race against time. This is why NASA and other observatories bring out the heavy hitters, not because they're dramatic, but because the window closes. Once it leaves, it becomes a faint point swallowed by distance, and you may never see it again. And yes, it has already done the most cinematic thing possible. It went behind the sun from Earth's perspective around perihelion timing, making it temporarily difficult to observe from our viewpoint, and then it became observable again as it moved outbound. That detail matters because it shows how fragile these observations are. This isn't like tracking a planet. It's like tracking a fired bullet through a storm with binoculars, while the target keeps changing brightness. NASA notes that astrometric observations resumed right after perihelion, and it remained observable with small telescopes in the pre-dawn sky for a time. Now let's talk about size, because this is where people get tempted to make stuff up. Scientists don't know its exact size because comets are messy. They have comas, they spit gas and dust. That glow you see isn't the solid nucleus, it's the material around it. So the nucleus size is usually constrained with observations and modeling. NASA's public estimate window gives a range. The nucleus is not smaller than about 440 meters across and not larger than about 5.6 kilometers, based on Hubble observations noted in their FAQ. That's a wide range, and that's okay. Science doesn't lie to sound confident. It gives you the honest uncertainty. And here's the part most people miss. Even if it turns out small, it still changes everything. Because the real question is not how big is it, Ig. The real question is, how many are out there? If this is the third confirmed interstellar object we've found, and we only really started getting good at detection recently, then the galaxy could be filled with these travelers. The Milky Way has hundreds of billions of stars. If even a tiny fraction of them eject debris during planet formation, gravitational interactions, or close passes with giant planets, then interstellar space isn't empty. It's a highway of leftovers. So how does something like this get ejected? Think of a young solar system like a chaotic construction site. Planets form, giant planets migrate, smaller bodies get scattered like gravel. Some get tossed inward and collide. Some settle into belts, and some in the wrong place at the wrong time get slingshotted out, escaping their star forever. Another way is through close gravitational encounters. A giant planet can fling a smaller body outward like a cosmic catapult. The result is the same. A comet-sized object becomes a wandering piece of interstellar shrapnel, carrying chemical fingerprints of its original home. And once it's out there drifting, what happens? Nothing, and that's the point. Interstellar space is cold and dark. Without constant sunlight, a comet can remain relatively preserved. Its volatile ices don't get cooked off the way they do in repeated orbits around a star. It's like freezing something for ages and then briefly thawing it when it passes near the sun. That's why an interstellar comet can be an even cleaner archive of primordial material. It hasn't been processed by thousands of perihelion passes. It hasn't been aged by our sun. It arrives with a history that's mostly intact. But then comes the second terrifying implication. If interstellar objects are this common, then planetary systems are not isolated. They exchange material, maybe not often, maybe not in a way that matters for life every day, but over cosmic time. Yes, material from one star system can pass through another, and that immediately triggers the question everybody pretends not to think about. Could life, or the precursors of life, hitch a ride? Not as little green astronauts, as chemistry, as organic molecules, as building blocks. Panspermia is controversial, and I'm not going to sell it as fact, but interstellar comets are exactly the kind of delivery vehicle that makes the question unavoidable. Now let's get more grounded. How are we observing 3I Atlas? This is where it gets cool, because one of the most underrated parts of modern astronomy is how many different tools can collaborate on one target. NASA's facts page highlights that multiple missions and telescopes are observing it, and there's even mention of specialized processing for certain spacecraft data. For example, NASA's STEREO mission, designed primarily to study the sun, was able to detect the comet by stacking and aligning multiple exposures, essentially boosting the signal from something that was expected to be too faint. That's a big deal. It means we can squeeze information out of instruments that weren't even built for comets, if the data processing is clever enough. And that tells you something important about where we are as a species right now. We are entering an era where our eyes are not just bigger mirrors, they're smarter pipelines. The future of discovery is not only hardware, it's computation, pulling faint truths out of noisy reality. That's why these objects will become more common in our catalogs. Not because the galaxy changed, but because our ability to notice has finally started catching up. So what should we expect from 3I Atlas specifically? Based on the public NASA overview, it behaved consistently with what you'd expect from a comet. Active outgassing, a coma, a hyperbolic path, and small trajectory perturbations compatible with normal comet activity. That's important because it keeps the story scientific. This is not a mystery object doing impossible maneuvers. This is a known class of behavior, just from an unknown origin, and that's enough. The origin alone is the thriller. But there's another layer that makes this story perfect for your channel. Perspective. When you say interstellar object, people imagine it close to us, like it's about to zip between Earth and the Moon. That's not what's happening. It's far. It's beyond Mars's region at perihelion distance, and Earth was even on the opposite side of the Sun at that time. The scary part is not proximity. The scary part is that it crossed the solar system at all. That means the boundary between our space and not our space is basically imaginary, a line we drew in our heads. Now zoom out. This is the third confirmed interstellar visitor we've recorded. The first was Oumuamua in 2017. Weird shape debates, acceleration debates, endless speculation. The second was 2I Borisov in 2019, more clearly comet-like, and now 3I Atlas. 3 points form a trend, and a trend forces a question. Are we about to start detecting these regularly? If yes, then the solar system isn't a sealed room. It's a place with a door that's constantly being opened, not by intention but by gravity and motion. Things wander in, things wander out, and we are sitting inside, trying to understand the traffic. So here's the real hook for the ending, the message your audience will remember. People stare at the dark between stars and assume it's nothing, but nothing is just something we can't measure yet. Interstellar comets prove that space is not a clean vacuum of emptiness. It's an environment with travelers. And if travelers exist, then history exists out there, carrying signatures from worlds we'll never reach. The galaxy is older than us by billions of years. If our own system can eject comets, other systems can too, which means some of the material drifting through the Milky Way right now could be older than the Earth itself, older than the Sun, a piece of an ancient system that died or changed long before humans even existed as an idea. And we're lucky, because for a brief moment one of those pieces is close enough to study, That is the miracle, not aliens, not conspiracy. The miracle is that we're finally building instruments and networks capable of catching these cosmic drive-bys and asking the right questions before they vanish into the night again. So the next time you look up and see the stars as a still image, remember that the universe is not still. Something is always moving. Something is always crossing. And right now, a comet from another star system has already passed through ours. And it's leaving with a secret we're still trying to decode. If you want, I can keep tracking updates on what we learn about 3I Atlas as new observations refine its size, composition, and behavior. But for now, here's the question that matters most. If our solar system has already been visited 3 times that we know of, how many times have we been visited when we weren't looking? And if the galaxy is throwing debris across star systems like this, then the darkness between worlds isn't empty at all. It's a corridor full of strangers.